12, and welcome to Purple Mountain Maths. Today we're doing the 2025 HSC paper for Maths Standard 2. This is part 4, question 23, 24 and 25, worth 10 marks. Question 23. Company A and Company B both issue an annual dividend per share as shown in the table. Based on the dividend yield, which company would be better to invest in? Pause here to try yourself. Okay, so this question relies on you knowing what dividend yield is. We'll call it DY. Dividend yield equals, by definition, the dividend per share divided by the share price multiplied by 100%. So the dividend yield for A equals the A dividend per share, 4.92, divided by the share price of 25.43. We're going to multiply that by 100% in order to express that as a percentage. 4.92 over 25.43 is this number times 100%. So it's 19.347%. Let's now compare that to the dividend for B. Okay, so the dividend yield for B equals 0.45 divided by 2.13 times 100%. Multiplied by 100%, I get 21.12676. 12676%. So clearly B is higher. So B is better because it has a higher dividend yield. Question 24. The population of snails in a garden is approximately 90. One night Bobby collected 18 snails from the garden. He tagged each snail and released it back into the garden. The next night 20 snails were captured from the garden. Approximately how many of the snails in the second sample are expected to have a tag? Pause here to try yourself. All right, when I do these recapture questions, I like to remember that what I captured as a function of the population is going to be in the same ratio as how much is tagged as a proportion of what is recaptured. You might like to remember cap per as just something, a little thing to remember. So I collected 18 out of a population of 90, and I have an unknown number tagged out of, when I redid it, 20 had been recaptured. Let's make x the subject of that equation. X equals 18 times 20 divided by 90. You might have to put that into your calculator. (18 over 90 of 20). The answer is 4. Question 25. In a research study, participants were asked to record the number of minutes they spent watching television and the number of minutes they spent exercising each day over a period of 3 months. The averages for each participant were recorded and graphed. Part A. Describe the bivariate dataset in terms of form and direction. Pause here to try yourself. Okay, so I'm looking at how I could fit a line or a curve to this data set, and I could see that I could fit a line, something like that, and that line means that the form is linear and it has a negative slope, so the direction is negative. Question 25 continued. The equation of the least squares regression line for this data set is y equals 64.3 less 0.7x. Interpret the values of the slope and y-intercept of the regression line in the context of this data set. Pause here to try yourself. All right, so let's interpret each piece individually. Let's first of all deal with the slope. The slope of negative 0.7 means for every extra minute of TV watching, exercising falls by 0.7 minutes. Or if you prefer, you could rewrite that in seconds. 0.7 times 60 equals 42 seconds. The y-intercept of 64.3 means a person who watches no TV would be expected to do 64.3 minutes of exercise. Okay, part C. Joe spends an average of 42 minutes per day watching television. Use the equation of the regression line to determine how many minutes on average Joe is expected to exercise each day. All right, so we're just using that line in the special case where x equals 42. So y equals 64.3 less 0.7 times 42. We can put all of that into our calculator. 64.3 less 0.7 times 42. We get 34.9. That's measured in minutes. Part D. Explain why it is not appropriate to extrapolate the regression line to predict the average number of minutes of exercise per day for someone who watches an average of 2 hours of television per day. Okay, first of all, we need to get those television hours into minutes. 2 hours of TV means 120 minutes of TV. Okay, we note this is far outside the given data set. This is far outside the given data set, which was only up to 60 minutes of TV watching per day. So it is not reliable to use the regression line for data this far beyond the data set. Okay, and that would be enough for 1 mark. If you prefer, you could try to use the regression line. At t equals 120, you would get y equals 64.3 less 0.7 times 120. So let's do that. 64.3 minus 0.7 times 120. And we get minus 19.7, but negative time has no meaning in this context. So you can see that that's nonsense.